Welcome to In 5 Minutes. We take problem on deflection of beams and we'll consider simply supported beam. Our problem statement is find slope at point A and D and deflections at point B and C for the beam as shown in the figure. So this is the loading diagram of the beam which is given. Also find the maximum deflection. Now take E equal to 200 gigapascal and moment of inertia I equal to 1 into 10 to the power 8 mm to the power 4. So in the problem our given data is E equal to 200 gigapascal or 200 into 10 to the power 9 Newton per meter square. Now since in this beam diagram the loads are given in kilonewton and the distances are in meters, we convert this E into kilonewton per meter square. So we have 200 into 10 to the power 6 kilonewton per meter square. Also the moment of inertia I is given as 1 into 10 to the power 8 mm to the power 4. Now which is equal to 1 into 10 to the power minus 4 meter to the power 4. And in this problem we have been asked to find first slope at A, second slope at D. Now we see point A and D are support points, hinge support at point A and roller support at point D. And third they have asked deflections at point B and C, so YB and YC. Also they have asked to find out the maximum deflection, that is Ymax. So let's solve the problem. We consider two vertical support reactions at point A and D as VA and VD. Now let's start with the solution. Our first step is to determine the support reactions, that is VA and VD, and this we determine by using static equilibrium equation, which is summation of m equal to 0 and summation of Fy equal to 0. Now on applying the first static equilibrium equation at point A, we have summation of m A equal to 0. Now writing the moment equation about point A for all the forces, we have, now about point A we have the first clockwise moment due to this UDL of 2 kN per meter acting for a distance of 6 meter. So we have a moment of 2 multiplied by 6, which gives the magnitude, and this UDL may be assumed to act at the center, that is at a distance of 3 meter from point A, so multiplied by 3. Then we have a clockwise moment due to this downward force of 5 kN acting at a distance of 9 meter from A, so plus 5 into 9. Then we have this anti-clockwise moment about point A due to this upward vertical support reaction VD acting at a distance of 11 meter from point A, so minus VD into 11. Now this whole summation of moment is equal to 0. Now on solving this we get the value of VD as 7.36 kilonewton. Since it is positive, it is upward. Now applying the next static equilibrium equation, that is summation of Fy equal to 0, that is summation of all vertical forces equal to 0. Now our sign convention is all upward forces positive and downward forces negative. So we have VA plus VD minus this force, which is 2 into 6, and this downward force, which is 5. Now this is equal to 0. Now substituting the value of VD as 7.36, we have VA plus 7.36 minus 12 minus 5 is equal to 0. So from this we get the value of VA as 9.64 kilonewton. Again this is positive, means it is upward. The next step is to write the bending moment equation by using Macaulay's method. Let us consider point A as origin. Let us take section XX across the beam and at a distance x from origin A, and move this section from point A, which is origin, to other extreme end D of the beam. Now writing the bending moment equation about section XX in a single equation applicable to all parts of the beam. First we make some adjustment in the beam. Now since we have taken A as origin, we add a UDL of 2 kN per meter between point B and D so as to satisfy the bending moment equation. Also, due to the addition of this downward UDL of 2 kN per meter, the static equilibrium of beam is disturbed. So to keep it at equilibrium, we also add this upward UDL of 2 kN per meter again between point B and D.